Hi Veer, good morning.
Hi, Maurya. Good
How are
morning.
you?
Good, Maurya. How are you?
Yeah, I'm good. Thank you. After a long time.
Mm. Okay, start one. Okay. Okay. In the last session, we saw that, right? How to deploy a Python application and then all the stuff. So let's see in this session or in this event, let's try to understand how we are going to do with the Git. Right. First of all, what is a Git? How this is going to be works, and then using this Git, which are the providers we are in the market. So using those providers, how to create an account? We're going to create an account on GitHub. Okay, this is one of the Git provider. Right. So we're going to be creative, and we'll create a sample project and then try to deploying it. Okay, so let's see that step by step. Okay. Last time we saw that how to configure this Nginx and then run our Python application. Now let's discuss about what is the version control system. All right, so generally why this concept is came into the market, uh, unable to track what the user is doing or an employee, how it is working, right? So any company can't able to track it in the initial days of 1980s. Right? So people are like thinking like, okay, they are doing, that's it. But they doesn't know really, this guy is working? Is this guy is really developing a project or software? How is doing? Now, whatever he did or whatever he make it, is it correct or wrong? Right? So there is no way to give a suggestions to that team member, right? It's become a very, very difficult. Let's say that is not only the thing. So keep on, let's say there's a software has been increasing days. On the time, let's say when you're doing the collaboration on a same software or a single project, what is happening? Okay, this guy has did something, that guy is going to do something. When you try to mod something, the source code, definitely somewhere else it is causing a issue. So all these are issues. It's a huge in 1980s and 1990s. So to avoid it, people are come up with beautiful concept called version control systems. By using this version control system, we can able to monitor what the developer or what an employee, how we did, how we modify the source code, and as well as how it is changed, when he modified it, why he's modified it, everything we can able to track it. Everything we can able to track it. Not only that, let's say that change is causing an issue on the market or for the software point of view, we can roll back his changes by simple one click. Right. So because let's say one of the guys modified, let's say user one modified lot of places in his source code, then suddenly we realized it that source code is causing lot of users is dropping or closing the app. Right? They are not able to use the app. Now, let's say bring back into the old version or bring back into the old code by simply roll back of those commit, or we call it as here commit. Those changes, if you can simply, it's a matter of 1 minute, you can able to roll back it and then bring back into this original or old version of the code. So that's all the system has been incorporated by using this version control system. But obviously, we need to be understand this version control system cannot be evolved in a single day or in a year. Obviously, it is going to be take a years. right? So every attempt, the people are come up with the different approaches, and that approaches, whatever the problems they have it, they are try to fix it. So in 2000, like around 2002 or 2003, our final version, you can say that, which is have supported by any type of a development or any type of an application or any type of a report. It doesn't matter. All these use cases is covered with that. So which is nothing but Git, which is nothing but Git. So before that, let's try to understand this version control system, how many types is came into the market. So those how it is fixed it with the help of different types. Let's try to understand. So let's say first thing is what the points I said, allow developers to track and control the changes to code over time and compare the versions of the code. We can compare it like what he did previously, what he did now, we can do that. So next thing is we can create a branches. We can create a branches for a specific point or for a specific source of code. You can create as a separate branch, make it like changes or you can do separately. So that revisions of this code, we can do that like a reviewer will be the code reviewer, will call them. So this code reviewer is going to be see that how we modify the code, right? He did by his own or is intentionally modified, everything can able to monitor by using these revisions. So let's try to understand. So that's what I said. So who, what, when, and why. So all these four things is going to be understand by using this VCS, version control system. So by using who modified it, what he modified it, when he's modified it, why he's modified it. So all those things, four questions can answer by this VCS systems. Now, let's say the first one is local VCS system, right? In the local VCS system, we have, let's say, every change you trying to do it, when you try to save it, it is going to be saved into the database. That database, we are going to call it here, it is version database. Version database, how we have RDBMS, NoSQL, graph databases. Similarly, there's a version databases. So these version databases, every change on a file, what you're doing, it is going to be created as a version. Like let's say the file is there. When you're trying to modify it, it is going to be when you save it and commit to this database, it is trying to save it as version 1, version 2, and version 3. Means every change is going to be saved as a record in a table. Right? So that's a little different of the structure compared to this our regular databases. This version database is designed to maintain our changes, when he did it, who did it, right? Why they did it, means by giving the option to adding some comments while you're saving. Right? So while giving the comments, while you're saving that changes, you can tell like, okay, I did this due to this reason, I modified this code. Now, if you click on submit or commit, then automatically it is going to be saved as a version on the version database. So generally this type of thing we can going to see on local computer. So this is the first thing is came into 1980s, which is nothing but we are going to call it here, it is local VCS. We are going to call it here, it is local VCS. So now local is solved, but the problem here it is when we wanted to be collaborate with the other users. When we wanted collaborate with the other users, has become a problem because this local VCS can be worked on one system and one computer. The project or software is developing by one person, that is okay. Or alone person, this local VCS system definitely will going to help them. But if it is say this in a project, two people are there, these two people from two different locations. One person is from Hyderabad, another is from Bangalore. Correct, right? It's a global. So people can sit somewhere else and then they can develop it. So now what has happened? Let's say that guy is doing in his system, this guy is doing in his system. But these both the guys changes is not able to come in one place. When you try to come into the one place, it's going to lot of conflicts. Let's say the developer 1, he did it A is equals to 10. Similarly, developer 2 is also did A is equals to 20. Now, obviously, on the same file, if you modified A is equals to 10, because developer 1, he made it for that some purpose, but developer 2 is also taken A is equals to 20. So due to the same variable name, somewhere else the logic has been broken. Right? Somewhere else, logic is definitely going to broken. So let's say obviously which one is the second or next line of A, that value is going to take it. Let's say A is equals to 20 is defined in the first, or A is equals to 10 is defined in the second, whatever, wherever the position accordingly, the A variable will be changes. When it changes, obviously it is impact on the other logic of, or whichever the line statements is written by the developer, definitely it will impact. Right? So not only this logical point of view, on the same lines, they are trying to modify it. When you try to combine these two files or single file, at the end of the day, the file has to run as a single file, correct? Right? Single program. When you try to combine this source code on a single file, what is happening? Again, which one I need to take it? Developer 1 I need to take it, or developer 2 I need to take it? No idea. So this local VCS is only perfect for which type of a person? The person can working alone. A person is working in a project as alone, or single person is handling the entire project. In this scenario, local VCS system is very, very good. But so currently it is not going to be, obviously collaboration is needed, lot of people supports is needed. So that's how local VCS is not helping to people. So that's how the people are come up with this central VCS server. In the next stage of release, the people bring this central VCS server. In this, what is happening? So computer A will be there, computer B will be there. Rather than keeping this version control system on their computers, trying to keep in the central based system, which is nothing but another third computer. That computer can access by computer A and computer B. But again, the problem is started in this central system. Reason, when say the central VCS server is went down, let's say computer A will not going to be work, computer B is not going to be work. Because entire VCS system has been kept on where, sir? Third computer. That computer is went down until unless it's up, the people has to wait for to bring back, and then they can start work on it. And also, it sometimes it can't able to recover also. This computer A and computer B sit silent for days also. Right? So this is another issue came into this when it's introduced in 1985s and 1990s. So that's how. So finally, the final version, what we are seeing in the market, right? What we are using in the market currently, which is nothing but, which one? Huh? Correct, sir. What is that? Distributed. We're going to call this one as distributed version control system, right? So in this distributed version control system, computer A is going to have a version control, and computer B is going to have a version control, and server is also going to have version control. Means every computer is going to have this version control. Means computer A, even if it doesn't have a connected with central server or third computer, he can work on his computer with the help of local version. Correct, right? Local VCS, he can, whenever he wanted, he can push it, or he can able to pull it at the time only. When he have an internet, or when the central server is back, and then at the time he can able to do this, until unless he can work on alone on his computer. Let's say even though central server has been went down, this computer A can able to bring the changes from computer B. Can able to pull the changes from computer B, because computer B is also have version control system. Means every side it's going to have a backup, right? So from, see, again, the server is also one kind of a computer. Server is also one kind of a computer. So computer B is also going to become a server when it's a server controller has become down. Understood, right? So this is the currently we are using in the market. So this one we are calling as distributed version control system, which is developed by Git, which is developed by Git. We can able to see this, right? So Git is open source. Git is open source purely. Is developed by Linux community. It is developed by Linux community. There is a lot of conflict history is also there, why they developed such a kind of a distributed version control. Because Linux community, they are giving the open source, especially in 1990s and 2000, they started giving this open source operating system to the market. At that time, which is giving by support by some of the companies to support the, right, this repositories or version control system to maintain this OS source code, they stopped it. They stopped it. So then whatever they're facing the issue with that, right, CVCS system, they are trying to build this DVCS in 2000, and they released on 2001 or 2002 by using one and a half year itself. They come up with this beautiful called Git. So in this, they solve a lot of problems. First one is the speed, right? So compare with this all other version control system, Git have little faster while uploading or while downloading. While uploading and downloading. So literally, when I'm saying that, when I'm pushing the code to the repository, means I'm uploading the files into somewhere else, which is nothing but third-party computer or third computer or fourth computer, whatever, wherever it is, we are uploading these files from our local to their computer location. So similarly, when you're trying to pull those changes from that repository or from that VCS system, you are downloading the files. Now it's little like compare with this others, this our Git is little faster, right, to upload and download it. So that's how you can say this. The Git is very good with the speed. Now another one is simple design. They didn't make very complex. They made very simple in terms of user perspective, not in terms of development point of the Git. Git point of view, the complicated code, but when you try to use this Git for user, it's very simple design. You don't need to be worried. By using the 4-5 Linux commands, you can able to push your changes, or you can able to pull those changes to your local machine. Now, it's a strong support for non-linear development. It's a strong support for non-linear development, thousands of parallel branches. Let's say, rather than in olden days, the people are doing before 2000, let's say someone is finished by module 1, thus module 2 is going to be start after completion of module 1. So this we call them as linear development. Once they complete the step 1, they'll go to the step 2. So nowadays, what is happened, that is gone. Now everything is a parallel. So let's say some team A is going to be work on module 1, team B is going to be working on module 2, team C is going to be work on module 3. So now, because it can be a parallel or it's a non-linear development, we are going to call it, when you are doing this, Git is too good to support such a kind of development environment. And it is supposed to thousands of branches. It is no limit for this. You can have a number of it. Now, this is a fully distributed, as I said, what is a distributed VCS system? We know that, how it will be works. Now, the Git will going to be support this fully distributed system. So Git is fully distributed version control system. Means computer A is going to have a version control, computer C is going to have a local VCS, and server is also going to have CVCS system. So able to handle large projects like Linux kernel efficiently, speed and data sizes. You can upload like the file size can be huge. Let's say you can upload like 1 GB or 2 GB, whatever the file size, you can able to upload it or download it with the speed and data size. These are an advantage. You guys can go to the website called git-sem.com, where you guys can download it, your Git, and install it. Right, so this is a very simple. Let me show you how it is going to be. Git/sem.com. once you comes to this website, you guys can see this, there is a download option will be available. So automatically detect which is the Windows or Mac system. So accordingly, there is a button will be there, download for Mac or download for Windows. So by clicking on this, it is going to become, so accordingly, you can just click on the next. This installation will going to be completed. Once installation completed, you guys can open your terminal. All right. So once you open this terminal, just typing like Git, you guys can see this, what are the options or arguments with this Git, what we can do. We can able to see like a help document. We can able to see this. Here you can see this. Here have to clone it, to initialize, to add, to restore, to move, remove. Every detail wise, everything it is there. What are those command? Means command arguments. We can able to see this. Right? This is a very beautiful one. So let's go back ours. Yeah. Right. So now, as I said, these Git providers are in the market. So many are there, like a GitHub, Bitbucket, GitLab, all are the Git providers. So using this Git, any one of it, you guys can take any one of it. They are going to give a free for users based on your size. I think 1 GB they are giving, right? GitHub is also giving for 1 GB, right? For a project, you can able to be use it. So you can able to create it, the repository there. Now let's coming into this, how this git init command is going to be works. So this git init is nothing but initialize a new Git repository. Right? In our local computer, we can able to initialize it by using this git init. Initializing this project when you are trying to be created. So let me show you one of it, how it is going to be. Right. So let me show you here. I'm going to be my workspace where I'm going to be create one test repository here. Let's say by using this command called, is it visible, right? So I'm giving this command called mkdir space. I'm creating a folder, nothing but. So I'm creating as test folder repo. I'm creating like test folder repo. So now once I created, let's navigate to that by using the cd command. So cd test folder repo. So now I'm inside of this folder. Let me check if any files are there or not. Let's use this ls command. It is currently it is a empty folder, right? Sorry. Now let's use the command by using init git space init. Automatically it is going to be initiated. So initialize this empty git repository in users viru workspace test folder repo /.git. .git. Whenever you initialize it, it is automatically going to be create this .git folder on that empty folder. Let me check that it is created or not by using, because the file or folder is started with a dot. We are going to call this an operating system side as hidden files. We are going to call them as hidden files. So those basically is going to be ignored. So now I want it when you're watching or when I sing. So that's why I'm using this option in the command by using -a. It is going to be not ignoring this, which is the files started with the dot. Now you guys can see this. There is a file has been created. Right, so it's automatically created. We can able to see here. Now let's go back here. Let's verify that status, git status. We can see this when it's created, right? When it's initialized, automatically one default branch is going to be created. That default branch name, we are going to call it as master. We're going to call it as master. So no commits yet, nothing to commit, create copy files. use git add to track the files. Right here, the flow, how it is going to be, let me tell you, right? So in the repositories or DVCS system or Git, how it is going to happen? When you added these files to this folder, when you added a files to this folder, it is need to be added to the track. You need to tell them, please try to track these files or folder when you try to modify or when you try to be added or when you try to be deleted. So that's how we need to be first by adding those files into the track, or to track to, we need to tell to this Git to saying that whenever the developer or whenever the person has been modified on these files, try to be monitor or try to let us know those changes also need to be pushed to the central VCS system. So that is going to be happen with the git add. So when you use this git add, it is going to be added to means you are selecting the files, which files you wanted to be pushed to the central VCS system. Once you did, after that, you just simply by using this git commit. By using the git commit, you can able to do this. Let's verify this now. I'm going to be create a sample file now. Please observe here how I'm doing. Let's say I'm using some VI editor, non-GUI based editor I'm using within the terminal itself. So I'm creating like one.py. I'm creating one.py. Now enter. I'm going to be insert mode where I can able to be add some file. Let's say first example, print hello. Right? So I added some print function and then just I escape it. Now shift colon WQ. Now the file has been created. It's saved. WQ means write and quit. Automatically files has been created. Now you guys can see now the file has been created, which is contains this one. Which one? Print function. We can check it if it what type of the content inside by using the cat command. We can understand what are this file contains. Right? We can see that. Good. So now file has been created. We need to be add to this. So let's verify this by using the git status again. What is trying to tell me? So last time when I used this git status, I don't have any files. That's why it is not saying anything. But this time there is a untracked files information is trying to giving to me, right? So what are those files is not, or those files which are not yet added to track, right? So here, that's what here saying this. It's clearly saying there's a red color it's showing to us where it is saying that you are not yet added to this tracking, right? So that's what. So use or to add it to this tracking, you need to use the command called git space add space file name or git space add space dot. Let's say I have more than one file, right? Rather than adding all the file names is become a difficult. So that's how in this folder, whatever all the files it is there, that's how in the third argument or third value is going to be as a dot means all the files is going to be happen in this included in that folder. That's how I'm going to be say this git add dot. So dot means this folder, whatever the files are there, which is not yet added to the track, let's add it to that. Right? I don't need to mention, right, which file you modified it. I'm ready to accept to push all the files. No, I don't want it to be push all the files. I want it to be some files only need to be pushed right now. Then you need to be mentioned those file names by using the space delimiter like git space add space 1.py space 2.py space 3.py, whichever you selected or which files you wanted to be pushed into the version database. Now let's see this git space add space dot. Now it's added. Now let's verify this git space status. Now let's see this. The red color has been changed to the green color. The red color has changed to the green color where you can see this. The file has been added to the track. So that's how it is showing the green color. Now this one, if you don't want it to be again, sir, I don't want it to be track this file. You can use this git space rm space dash dash cached space file name. Or else you can use this dot, whatever added this files, it's going to be removed it. So let's test it out how it is going to be. So git rm dash dash cached dot, right? So what is going to happen? It has to remove whichever the files we added to the tracking, all the files has to remove. And then it again, if you use this git status, it has to show in the red color. So let's see this. Okay. Now it is removed because dash R recursive. It's have a multiple. So that's how I added it is removed. Again, go back into this git space status. Now it's came in the red color again. Means you can select it which files you wanted to be commit or which files you don't want it to be. You can unselect it by using these two commands. By using the git add, you can select it, those which files you wanted to be save it on the version database, or else if you don't want it, you can unselect it by using the git remove dash dash cache dash r dot. If you use it automatically, it is going to be unselected. Now let's select it. All the files now. So now it is all selected. Now ready to push. We need to be push this to the version database or commit to local VCS because I still doesn't connected to central VCS system. I'm still working on my local VCS system. Correct, right? I still not doesn't mention either GitHub or Bitbucket. All the places are not even connected to this local VCS. So that's how. Let's commit it. Git commit by using m dash m. Dash m is nothing but message, right? So by using, whenever the people read this message, they can understand why you did this changes, why you did this changes. So message is mandatory when you wanted to be saved these changes on the version database. So that's how here what I'm doing. I'm just saying first testing code and given some comment here, right? Now enter. Now let's see clearly. It's saying this one file changed, one insertion. Line means one line has been inserted and created mode is 1000644 1.p5. It is has been saved on the version database. Now let's verify this git status. It's clearly saying the branch name is master and nothing to commit. Working tree is plain. Working tree is plain. So means whatever the changes did it already, it's saved on the version database. It is not going to ask you to do it again because this once it is done, done. Right? Again, let's modify it. It is going to be show you to asking to commit or untrack those changes. Let me show you again. I'm going into the 1.py. Now let's add it here by giving a variable or defining a variable. So let's say I'm adding a is equals to 20, b is equals to 10. Okay, so now I did it. I modified this, means added a two more new lines. Now, obviously, if I go to this git status, again, so let's see, it's clearly saying that. So the changes not staged for commit. So whatever you modified on the 1.py file, right? So this started tracking, it's understood you did some of the changes. Those changes, it's not yet selected for saving onto the version database. That's what it's trying to say. So now you can able to do it by using same thing, git space add space dot. Now it is added. Now let's commit by using git commit minus m. Now you can give say added a variables or define a variables. Define a variables. Okay, so now if I say this enter, now this time here it's clearly saying that one file is changed, two insertions, because we know that I added a two lines in this 1.py. So it is understood and saved it. Now let's see this, whatever I said, sir, every change, whatever we once we committed is going to be created as a version. Let's verify this log is really created or not by going on to this git space log. Sorry, git space log. You guys can see here when it's modified, who modified it, It's clearly it is there. Correct, right? So this is the two changes I made it. The first one is first testing the code with the commit I, which is nothing but version number, right? So commit ID and who is the author, when it's modified it, why is modified it, right? So similarly, you can able to see this, right? Who's modified it and then when it's modified it and why it is modified it, you can able to see this. Right? So this is all the non-GUI. This is what is going to be happen, right? Without the GUI on the terminal, right? This is where it is going to be happen. So when you say this is a GUI, we already have a lot of desktops or web apps are there. Example, GitHub itself is providing the GUI to do that, right? So you can create a repository there, whatever I did it here, git add or git initialize, everything you can do it from the github.com also. Let's test it out first by going on to this github.com. You guys can open yours by going into the github.com. So you guys have a laptop, please open. And there is an option called sign up. If you guys have it like creating this account by going there, enter your email address and all those details, account is going to be created. Once this account is created, let me try to log in here. Right. So now once you came, so you can able to be create by clicking on the new. So when you click on this new, there you can able to create your new repository, which is nothing but git initialize what we did it on our local. Now I'm trying to do on CVCS system, which is nothing but central version control system. Now the repository name I'm trying to be mentioned here, let's say demo on Git, right? So I try to enter, it's trying to look on this in my profile with this name. If any repository are there, it is trying to look on it. If it is not there, it is going to say available. If it is already tried to use the same name, it is going to say that it's already exists. Like creating a folder, how would it by using the mkdir and git init? Those two steps is going to be happen here. So now you can give a description. I don't want it currently. Let's leave it. And then let's say the public and private. So there is a two options is going to be provided by central VCS system. One thing is anyone can access or anyone can view this repository. You can use the public. You don't want it to be give access to anyone, or that should be with your account or the person you wanted to be collaborated. That guy only need to do that. Then you need to choose the private. Right? So let's choose this private. So now I'm not initializing or adding any files right now. Just create a repository. It is going to be created and it is going to be created in the URL like this, your github.com/your username and your repository name. This is the URL structure is going to be happen on the central VCS system where the provider's domain name /username/repository name. Right? So in this, you guys can see currently we don't have any files. It's trying to either by using this from your local, try to do it, or else if it's already existing repository, let's add it to connect that one. And now let's push these changes to here. We have already created one of the local repository, right? Already existing local repository. Let's try to connect it now by using this git remote. By using the git remote command. So which is saying that we are simply saying to that local repository. So your central VCS system is nothing but so github.com/virumandli/demo git.git. So now let's do this. Let me copy this one by one. Right? I added this git remote add origin from my local to this thing and git branch, and I modified it. Let's try to push it. Now automatically it's pushed. Now let's try to refresh. Now we can see this, whatever I did in my local machine 1.py has been pushed onto this GitHub, which is got here is 1.py file. Now, if you try to open here, I can able to see this, whatever is the file is there in that file, what are the content is there, we can able to see this. And from here also, we can able to modify it by clicking on this edit the file. So let's say I'm modifying this file here. So here I'm going to say print A and next print B, something I did it, and now commit those changes, right? So now whatever we are doing, git add dot or git commit space dash m space message, whatever we are giving, everything will take care of by this GUI. Now simply you can add your commit message, and if you wanted to be adding some extended description also, you can add it. If you don't want it, you can directly commit those changes. Now those changes has been done. Now we can able to be monitor what are those changes, who's these changes by going on to this total commit. So up to now in my local VCS system, it's happened the 2 commits. In the central VCS is happened 1 more commit. So total 3 versions has to be created. You guys can click on it. You guys can click very clearly. So first testing code, define a variable, and next one is update 1.p1. Now, those changes, let's try to pull in my local VCS system again by going back into this terminal here by using which ones are git pull. So because if I use this ls, whatever I have this 1.py, what is this contains? It's have only a 3 lines. Correct, right? It's have only a 3 lines, but really the file is already updated in the central VCS. It's currently it's have 5 lines of code, correct, right? That has to be updated. So that's how I'm going to be used git pull, right? So let's use it. It's trying to be pull those changes. See clearly 1.py file has been modified and it's added 2 lines. It's added 2 lines. It's trying to tell me, right? Plus plus means 2 lines has been added. Minus minus means the 2 lines has been removed. Correct? In this scenario, let's say plus plus means 2. 2 lines has been added. Now the 1 file has changed and 2 insertion is changed. It's clearly trying to give some information to me. So now let's go to this again. ls, I have a 1.py file, still it is there. Let's use this cat command to print out what the inside of the file. Now previously have a 3 lines. Now it contains the 5 lines. Fair try? So this is the way people are going to be share their source code and then try to merge it on the central VCS system and then try to pull those again into their local machine. This way the people are going to be work on it. So that's what here I try to explain in this. That's what here going to happen with the git init. Next is git clone, right? So whatever by using this, right? So which is nothing but without initiating, right? You don't need to be initiated. By using git clone from the central VCS system, you can initiate it on your local VCS system and directly connect it to central VCS system. So both is going to happen by using the git clone on this here. So clone and create a local copy of your remote repository. That's what is going to happen on this command. Next one is git config list. It is going to be clone and the not clone. It is going to give the list of configuration information on that local repository. So globally, you can able to set your name, right, for your repository when you're committing currently. You guys are seeing the author name and author email address, correct, right? When you go to the git log, you can see there, right? So all those settings you can able to be modified by using this thing. Now, next thing, this is for local repository. And now let's say creating the branches. This is the most important. For this, we can create a multiple branches. These branches by using this git space branch name. You can able to be created, right? So generally we saw by default when you are initiated or when you created a new repository or when you clone it, whatever the repository is there, it will come. But when it's initiated, it's going to have one default repository, which is nothing but master. So we can go into call them as main also. That is not a problem, right? So it depends on the providers. Sometimes we call it as main, sometimes we call it as master, sometimes we call it as production. Depends on it, we can change that by using the command called git space branch space -m space this new branch name automatically will going to be changes, right? So that's a renaming the branch name, right? That what is going to be happen. Now to create it, you need to be create a git branch name like a creating it will going to happen. After that change from one branch to the another branch, we are going to be use this git checkout. You're going to say that git checkout. Let's say that's what I said, non-linear development. That can be possible by creating the multiple branches here. Let's say there's a one website they are building that application or web application have authentication and they have like posting a reels, they have a timeline page. So all these are different modules and different pages is doing by every department, like team 1, team 2, team 3, they are doing. So let's say team 1 is going to be keep the branch name as login or authentication. Team 2 is going to be create a branch name as timeline page. So team 3 is going to keep as a reels. Like 3 branches, they are going to be happen. These 3 branches you can merge onto this main branch or master branch or production branch. Means all these source code you can able to be merge it on a single place, which is going to be main or dev, whatever. Right? So that's what to merge it. We are going to be use the git merge branch, like combines the specified branch history into the current branch. Right? So we can able to be merge it. This is usually done on the pull request, but is important on the git. So let's say that's what here happened. So now to delete, obviously, we are going to be use this -d. So git space branch space -d space branch name. We are going to use it to delete it. Now on the GUI side, just simply right click on it and delete. It is going to be deleted, but the command is saying this one. So now let's try to understand this Git flow. Last time also we saw this and just giving an idea about it, how this Git flow is going to be works. So in this Git flow, what is going to happen? Let's observe. So let's say there is a one master branch is going to be there or master main, whatever, right? This branch, this we call them as default branch. So this default branch, people are going to be create a feature branches or release branches or development branches, right? So they are going to be created that, and from that, they are going to be add the source code or modified it, or they are going to be verified, whatever they can do it. And after that, they are going to commit those changes, means save those changes on the version database, and then try to give this pull request to that default branch. When you give this pull request, so generally when you doesn't have it, right, there is no code reviewer or any person is not there, it's directly merged into that default branch. But here, if you go with this, if it's have limited access, you don't have an access to this default branch because there's a code reviewer will be there. Code reviewer will going to be review your changes, why you did it, why when he's did it, right? What is the issue or anything? All this, they are going to give some comments, right? Accordingly, you need to be modified that source code. Once the code reviewer is satisfied, is trying to be merged into the default branch, which is called master, main, or production, right? So this is the Git flow is going to be happen on the real time, right? So to create it again, so let me see this. Let me see this. We saw that, right? Git space branch. So we have a main branch, correct, right? So previously we have a master, we renamed to main. When you are trying to, or when you are trying to connect it to the central VCS, we give a name as main, right? So now let's try to create a new branch. How we did it? Git space branch space. Let's say I'm going to creating like login and enter. So there's a new branch has been created. Let's verify that the branch has been created or not. Yes, it's created. The login branch is being created on my local. Now I want it to be from main to shift to the login branch. Correct, right? So that's how git checkout space login. Now I switch to branch called login. Now in this, let's see, do we have any file? Yes. Whenever creating from which active branch, we are creating a new branch. In that active branch, whatever the files, folders, assets, everything will be there. It's going to take it and create a copy version on that newly created branch. So that's how we have a 1.py have a file, it is there. So now let's edit this one by going on to this 1.py. Here C is equals to A plus B and print C. Now write and quit. So I saved it and then modified it. If I do this git status again, it is going to tell me same procedure. The file is not yet added to the staged. So that's how git space add space 1.py. This time rather than dot, I'm giving the file name. So just see this git add, right? 1.py, it is added. It's turn it out into the green because it has been selected. So now let's add it. Git saying that added the sum. Now enter. So the one file has been changed and two insertions has happened, right? So now by going on to this git status, you guys can understand this. The current branch name is login and then nothing to commit and working tree is clean. Right. So now go back into the main, what we have it. So by using simply git checkout main branch, right? I changed means I switched to this main branch. So now let's verify that whatever we modified on the login branch, those things is available on the main branch or not by using the cat command. Sorry. Now, whatever we added C is equals to A plus B or print of C is available here? No. No, we don't have it. Right? So means that branch changes is going to be with that branch and this branch changes is going to be with that branch only. And also, if I go to this central VCS, right? So if I go back, right? So whenever I come to this, I can see this only one branch is available. So there is no login branch because this login branch is still happen on my local VCS system is not yet pushed to the central VCS. Now we need to be pushed. So going back again. So let's switch back again by using git checkout space login. Now let's try to be git push. What we can say? Just that's it, git push. Let's see here. It is trying to ask you to set this upstream or which one, right? Origin, it's trying to do this. I'm going to say git push, right? So I can use this like which one to do this. Obviously, it is helping me to track whatever the file changes is going to be happen. So I'm mentioning this remote repository name and their branch, what it is. Now let's observe what is going to happen. Now it is pushed. Now I can go back and refresh it. I can see this. Currently we have branches login. Now in my local is active branches login. So that's a here also active branches login. Because I said set upstream, I mentioned on this when you're pushing, automatically whenever changes on this, it's also impact on my central VCS system. Now going back onto this, let's see this. The code is also, it's available or not by going on to the login, right? So let's see this 1.py, we have it. So whatever I added, C is equals to A plus B and print of C, it's there. But if I change it to this main branch, so we don't have those lines. And if I go back and then GitHub, how its intelligence is trying to tell me login had recent changes, is pushes in 50 seconds ago, but it's not because this login branch has been created from main branch or master branch. It is not yet merged these changes into there. So that's how it is asking to create and compare and create a pull request. That's what it's asking. If I click on this button, it is going to show, let's please understand. From login to main branch. Login to main branch. Before giving this pull request, it's going to be compared. And then if you have any conflict, it's going to be tell us. Currently, I don't have any conflict. It's trying to tell me, right, what are these commits has happened between these two branches, which one is ahead, which one is behind. According to those, it is trying to show me that one commit is ahead or behind of this login branch. So that's how it is trying to show me which commit it is, which are the how many files has been modified, which are those files, and what are those changes. What are those changes? We can able to see it, and who is the contributors. It's a single or multiple. We can able to be see that. Now everything is fine for me. I can see I compared it because the GUI is helping me to understand what are those line changes also. Now by clicking on create pull request, right? Automatically it's trying to be merged because as the user, I have an ability because I'm the owner of this branch or repository. So that's how what has happened, automatically merged those changes onto the main branch. So now if I go back into the code and see here, if I'm in the main right now, let's say it is updated 1.py. Let's observe here, it is updated or not. It is updated, sir. Why? Huh? Still, because see here, it is a habit, but I didn't given this. Compared it, pull request has happened, but finally I didn't accept it. I need to be accepted those change into the main branch. So that's how until unless I said like merge this pull request is not going to be happen. So that's how I'm saying that merge the pull request. Confirm merge. Now it is changed to merged. Now previously pull request we have a 1. Now it's become a 0. We don't have it. Now see this, it's clearly merged. I can go back into this and see this. Previously the last commit added the sum also came on the main branch. If I go to the 1.py on the main branch, I can see these two lines. Understood? So this way the code, the file, whenever the file changes is happen, is going to be happen here. Understood, sir? So this is about the basics about the Git, right? So this is I took one of the provider, which is nothing but GitHub. You guys can take Bitbucket or GitLab and try to understand any one of it. So rather than rather than .py for data analysts, data science guys can use this IPYNB files. IPYNB files, you guys have it. You guys also save it on your repositories, right? And not only that, you can commit the PDF files, documents, data sets, everything you can push it into the repository. Any assets you can able to be commit, that is not going to be harmed. Any data type, content type, it is going to be accepted by the Git. So because we are going to have a limit of 1 GB, please try to very careful, right? The files should not have more than 1 GB. As a free account, we have a limited, obviously. Right? So obviously, when it goes to the company, it's going to be have an enterprise editions accounts. So enterprise editions, obviously, there is no limit. There is a different features are going to be there. Now, for this repository, I can invite these other team members, right? I'm the owner of this repository. I can go to the settings, right? There is an option called collaborators. There's an option called collaborators. Here I can invite the people because it's a private repository. It cannot able to be visible to them until unless I invited them. So once it's invited, these guys also, the collaborators also need to be accepted. Once they accepted only, it is going to be visible for them. They have an authority like either accept or reject. They have a both. So let's say based on their wish, they can do whatever. If they accept it, they can also in their profile or in the GitHub dashboard, they can able to see this repository. They can click on it and go there and then work on it. So if it's these commands, if you guys are, if it's difficult, there is another option for based on that GUI. Let's see, GitHub desktop. GitHub desktop. Right. So this is a GitHub desktop. This is a purely GUI. So it's a desktop app. You guys can download it. And now that you guys open your local folder on the VS Code, try to edit and modify it. The desktop can able to be track it here and select it or unselect those files. By default, it is going to be selected, which is nothing but git space add space dot, whatever the commands is executed, everything by doing a manual, by giving this commit and then click on this commit, automatically it is going to be push and pull, right? So it is going to be happen with your remote repository, right? It's easier. It's too dead easy by using the GitHub desktop. You guys can try it out. It's very easy. Please trust me, right? It's very useful also. Similarly, for when it comes to the Bitbucket, they are going to be use the source tree. When you come to the Bitbucket, they are going to be use the source tree, one of the famous GUI tool for Bitbucket. Similarly for GitLab, so XYZ, like every repositories, third-party repositories, they have their own GUI to handle such a kind of a stuff. So or else you can directly use this commands, whatever I showed it, it will be work. It doesn't matter, irrespective of the Git providers, it is going to be works. Irrespective of the Git providers, it is going to be work because all these Git providers is going to be use this Git technology. Understood? So by adding this remote and pushing, pull, everything is nothing going to be changes. But the providers have little differences when you're coming into the features on their platforms. Clear, sir? Anyone have any questions on this? Anyone have any questions? Online? Yes, sir. Module. It's a module based, you can say, or features of that particular app or functionality the people are going to be created, or else release point of view. In a release point of view, let's say you are going to have in a working environment, environments will be there. Let's say development environment, testing environment, pre-production, nothing but UAT and production. Generally, we call them as dev, SIT, UAT, and production. These are going to have a 4 environments is going to be there. It is not mandatory you are going to have a 4 environments. It might be changes. Let's say that project based on the budget, they have that many instances or that is available or not, totally depends on it. Some projects might be have 2 environments, some projects might be have 3 environments, whatever, right? So in this, what is going to happen? You need to be, when you're releasing the code, you cannot give with the code have a lot of bugs to the testing team. Am I correct? If you give lot of bugs, whatever that code, if you give to the testing team, they are going to give lot of showstoppers or buckets or bugs. They're going to be created bugs or a showstoppers. So obviously what is happened? For a developer or for report developer or for an application developer or for a data scientist, if you're seeing that many issues means that management is going to ask you, what is going on? What's happened to you? Why these many bugs are came? Yes or no? So that's how the people are going to have for internal, for developers. Developer can be anything, application developer, report developer, or it can be a data scientist, all are developers only, right? So these developers, what they are going to do, they are to test it out, they're going to have a development environment, right? Once they feel they have so confidence, so that we call them as unit testing by ourselves. So once this unit testing is done, but ourselves in the development environment, that code we are going to be shifted to the release, branch, going to be sent it to the release branch. So means your code in the dev branch, when your code is in the dev branch, you feel like you have a confidence, you're going to be create a new release branch. Create a new release branch. That release branch, you are going to give it to the SIT. So means testing team keep on testing whatever you given for the releasing. So parallelly, you can do it other features in the development branch, because that point of time when you feel like I'm confident, that code they are testing because it's have a less bugs. Maybe it will come from the SIT, from testing team, that you can solve it. That is not a problem. But here, there's suddenly one more new feature they ask you to develop it. I can develop on dev branch. So parallelly, new development is going to happen. Similarly, testing is also happen for your previous. Understood, right? So means release source, release branch. We call them as release branch. From release branch, let's say whatever they said, no, this issues are there. Rather than the dev branch, you are going to be do on release branch. Those fixes you are going to on release branch. Once it is done, the SIT given approval, and then you're going to push it to the main branch or master branch or production branch. Right? Once you push it from there, it is going to happen to release to the pre-production, which is nothing but UAT and production. Understood, sir? So this is the flow is going to happen. That is depends on the companies. Let's say you don't have testing team, you don't have UAT and production, you are only the solo person, you need to be release it, then you can directly release it. You can directly release it, nothing will happen by keeping only one branch, which is nothing but main branch. All your Power BI reports, which is nothing but .pbix. Correct, right? .pbix, right? All those files you can commit into the repository. Right? From this repository, you can able to push it to this Power BI service. So that will take care of by the DevOps team. That will take care of by the DevOps team by enabling the CI/CD pipelines. By enabling the CI/CD pipeline. So that kind of a things is going to be happen. That's a Microsoft connectivity. They are going to do it. You don't need to worry. So up to now, you need to commit this thing to this where from there they are going to take up. Understood, sir? Any questions? Merge, when you're trying to merge into the main or master branch. Memory means size of this, obviously same only. Na? Why it will be more? Obviously, let's say the line number, it's okay. In a file, how the size is going to be decided, any file size, based on number of lines? Can I say that? Generally, if you say like 1,000 lines, the file size more. If you have 10,000 lines, more, correct? Right? So these number of lines, how many you are going to have in the development branch? Same number of lines if it is going to be there on the main branch also, right? Then the file size is same. The file size is same. So, but this is going to be happen on the database, sir. Please understand, not on the folder. Which type of a database? Version database. Version database. So it is all these files are going to be saved on the database. Understood? Any questions online, offline? Clear? Okay. Chalo, thank you guys. And if you guys have any queries, please post it on about this. We're going to be given answers. Thank you guys. Have a nice weekend. Thank you.